Hello again. So at this point in the class period, you should have completed the iron on a bag activity and then checked your answers and corrected them if any of them were incorrect. So what we're going to do now is we're going to do a note sheet for Learning Target 3.3, which deals with ionic compound formulas. So the first thing we're going to do is we're going to label this new note sheet as Sheet 8. And the note sheet is called Naming and Creating Ionic Compound Formulas. If you don't have the sheet, you should pause the video and grab a sheet from the sub. So the first thing we need to do is we need to define what an ionic bond is. Now an ionic bond is the force of attraction. It's a force that creates a chemical bond between ions of opposite charges. So ions. An ion is what we've been talking about these last couple of days. And this opposite charge they're talking about right here are oxidation numbers, what we've been working on in our second learning target with those superscripts. So ions are atoms that have gained or lost electrons, which is what we've been talking about with anions and cations. Monatomic ions are single atoms that have either a positive or a negative charge. So when we talk about an ion, we're actually talking about a monatomic, like mono is one. Now polyatomic ions are groups of atoms acting as a unit. So remember how we were talking about that hydroxide? That's a polyatomic ion. That O and the H, that oxygen, hydrogen, are bonded and are acting as a unit, and they have an overall charge. So an ionic bond is formed when electrons are transferred between atoms. So one atom is going to give its electrons to the other one, and they're going to be connected that way. So atoms that create ionic bonds need to have their positive and negative charges cancel out, so they'll create a neutral compound. So that means the sum of the oxidation numbers, which means if we added them together, it's going to equal 0. Ionic compounds are usually created between a metal, which create positive ions, and a nonmetal, which creates negative ions. And fun fact that you're going to need to know for your exam, ionic compounds usually are solids at room temperature. So just as an example, table salt is an ionic compound. It's a solid. You can sprinkle it on your food. So there are two things we need to remember about naming ionic compounds. The first thing we're going to do is we're going to write the full name of that first element. And the positive element always goes first. So then, well, how do we know if it's positive? Well, it's the one with the positive oxidation number, so the metal. And the second thing we need to remember is we're going to write the name of the second element, but we're going to use IDE as an ending. So, for example, lithium, which has an oxidation number of +1, which is why it goes first, and sulfur, which has an oxidation number of -2, which is why it goes second, would be called lithium, because I'm going to write out the full name of that first element. And then instead of sulfur, we're going to take off that ending and write it as sulfide. We have that IDE ending. The second teacher example is MgBr2. Now Mg is magnesium, and it has that oxidation number of +2 because it's in that second column of the periodic table. And Br, bromine, is -1 as an oxidation number because it's in that halogen family, like one right off of the noble gases. Now magnesium goes first because he has the positive oxidation number. And because he's first, we're going to write his full name. So magnesium. And then Br stands for bromine, but because it's an ionic compound and it's second, we have to take out that INE ending and put IDE. So it'll be bromide. Now I want you to pause the video and I want you to try CaO. And when you do it, you should check your answers. Now Ca has an oxidation number of +2 and oxygen has an oxidation number of -2. Now because Ca is positive, it's going first, so it'll be calcium, figure out that whole name for that first one, and then oxygen. Now the second rule says we have to use IDE as an ending. So instead of oxygen, we're going to cut off a lot of that, and it's going to be called oxide. Now, if you tried it and got most of it right, nice work. If you tried it and got it right, way to go. But either way, you should make sure you have this written on your paper. Now we're going to learn how to put two elements together to create a neutral ionic formula. And the first thing we're going to do is we would look up the oxidation numbers for each element that shows the charge of its ion. So you're going to need to take out your periodic table if you haven't already. Then what you're going to do is you're going to write the symbol, like the element symbol, for the positive oxidation number first. Then you're going to write the symbol for the negative oxidation number second. Remember, it goes positive always goes first. That metal is always going to go before the non-metal. Kind of like reading the periodic table. The metals are on the left, the non-metals are on the right. Same thing in our formulas. The metals are going to be on the left or first, the non-metals are going to be on the right or second. So this is where there's some math involved. So we have to remember that ionic compounds are neutral. So we would have to determine how many atoms of each element you need. So the sum of the oxidation numbers is equal to 0. And when we find that out, we're going to use a subscript. So let's do a couple together. So calcium, which is Ca, I'm going to look at my periodic table, and I'm going to say, okay, so the oxidation number is +2. Cl stands for chlorine, which is in that group 17 column, and his oxidation number is -1. Now, okay, so if I had one Ca atom and one Cl atom, I wouldn't have an overall charge of 0 because I have +2 and -1. Now, I had to think to myself, how can I get this to be neutral? And my answer is going to be, well, I need 2 of these. So I'd have 1, so times 1 calcium, which would be +2 as an overall charge of the calcium atoms. But if I had 2 chlorines, that means I would have a -2. And +2, and if I -2 from that, that's 0. So I would need 1 calcium atom and 2 chlorine atoms in order to get a neutral compound. So I have Ca, I'm not going to put a subscript because I only have 1. And then Cl, and because I need 2 of them, I'm going to put a little 2 down here as a subscript. Let's do another one together. So Be, that's beryllium, it has an oxidation number of +2 because it's in that second column. Now O is in column 16, which means he's going to have an oxidation number of -2. Well, isn't it super convenient? If I have +2 for beryllium and -2 for oxygen, I only need 1 of each to cancel out. But let's prove it. So if I do +2 minus 1 times 1, it's going to be, just normally +2 because it's times itself. Oxygen is -2, and if I only need 1 of them, then the charge is going to be -2. Now again, if I have +2 and then I take 2 away, I'm going to be back at 0, which is exactly what I want. So my formula is only going to be Be, and only 1 of them, and then O, and then only 1 of them. The last one we're going to do is phosphorus and barium. So phosphorus has a charge of -3, and barium has a charge of +2. Now I have to look at this, and I have to think of my lowest common multiple. So between 3 and 2, what I would do is I would multiply them together. So the common number here is 6. Now in order to get to 6 with -3, I have to times it by 2. So that would equal -6. So now in order to get to 6 with +2, I would need 3 of them. So that would equal +6. And if I have -6 for one atom and +6 for the other, if I add those two numbers together, I'm going to get to 0, which is exactly what I want. Now you have to think to yourself now, okay, so which element goes first? Well, it's the one with the positive oxidation number. So we're actually going to put Ba first in our formula. And I have 3 of them. So then with P, that's my -1, so it's going to go second, I have 2 of them, so it's going to go here. So barium phosphide is Ba3P2. Now some of you might have noticed that we would just be cross multiplying here. So look, we have positive 2 here. That's our oxidation number. That's how many atoms we need of chlorine to cancel it out. And these numbers going diagonally are the same. It's the same thing in this example for the most part, but it's fairly easy because you only need one of each. And if you look here, we have an oxidation number of -3 for phosphorus, and we would need 3 of them for barium. And the same thing going from barium to phosphorus. It's the same diagonally. Now what I want you to do is I want you to try these 3 examples on your own on the back. And when you're done, you should check your answers on the board. So you should pause the video when you're done and check your answers on the board.